Okie dokie, it is time. Okie dokie. Procedural announcements. Finals next week. It is Monday. And if I recall correctly, 4:50. Anyone remember for realsies? I have trouble with the hours. Okay, 4:50. Anyone want to ask about the equation sheet or the number of questions? 40 questions. Half sheet of paper, front and back. It is cumulative. It is evenly weighted. Yeah, sure. Whole sheet of paper one-sided or cut it in half. My strong suspicion is that you'll do better if you don't spend 18 hours making the prettiest equation sheet ever. I'm putting more restrictions on the equation sheet than last year, and my suspicion is that the exam scores are going to go up slightly. Well, I'm going to get a little bit better each year at teaching. Incremental progress. Question. I uploaded this. Now, please note this is the original exam 2 file, so there are still typos on here. I will correct as we go along. Sorry. I will try my darndest to fix and re-upload probably tomorrow. Let's try that again. Other announcement. I did my first stab at uploading the participation points, and of course I screwed it up. The second and third months are entered as a quarter of the weight of the first month. That's wrong. That will be fixed. That's not that hard to fix. I can fix that in a relatively short period of time. Sorry for all the freaking, yeah. In previous semesters, in previous years, I've had a policy whereby you have to get a certain score on the final to pass or a certain score on the final to get an A or a B. I do not have that this year. If your weighted average is a pass, then you get a pass. Two questions from students from last period. Is the final cumulative? Yes, for the 1000th time. It is cumulative. It is evenly weighted. We have done 4 modules. There will be 10 questions on each module. And what was the other question? Oh, is the final optional? Not unless you want to drop your grade 2-letter grades. The final is, I think it works out to 22% of your semester grade. So if you skip it, I mean, I'm not going to burst your door down with my final exam police and drag you kicking and screaming to the exam room. You could skip it, but your grade will go down 20%. So yeah, I think these are important. I want to see that you actually learned something this semester. Best of all, that you learned and internalized it, not just in short-term memory to pass a test, but understood it. Yeah. I think what I said is no. No? Yeah, this should be loaded on Canvas. Look at Canvas files. Really should be there. Okay, so last questions. Any other questions, procedural questions about the final, about what we're doing this week? Yeah. Final is in here. Great, let's do things. Okay, so after we did exam 2, people requested that we go over it, and I had the brilliant idea, not to brag or anything, but to go over it when would be most useful for you to have these skills again. So that's today. We're going to get through the 3 o'clock class got through question 17. We're going to spend some time, spread it out, go through questions 1 through 17, thinking about them, trying them again, and then discussing them. So you actually learn something instead of just write down a bunch of letters. Next class will be an overview of everything, This is an exam over one module. We'll have one more chance to do a brief overview of everything on Wednesday. Of course, the homework which is due this Sunday, the quiz which is due this Sunday, the last year's final, which will be uploaded shortly to Canvas, the office hours, the SI session, the lab practice final questions, all these other resources will also be cumulative, let you practice a sampling of everything. Okay, yeah, I think that's all that I needed to say before we get into it. Let's get into it. Take a minute, look at questions 1 and 2 and put these in the Google form. I encourage you, do this with each other. Oh, right. Sorry. No, actually, last announcement is I will, in a little bit, I will announce the people who are not being entered anything into the Google form. So this is not to shame anybody, but this is to maybe let you know if for some reason you are continuing to forget to hit submit response. This will hopefully give you a kick in the pants and make you hit submit response. Or if there is a known error that's not affecting anybody else in the class, maybe you can ask me about it. Anyway, you have been warned. Where does that go? 2 minutes.
I got $68.
Hey, number one, correct, as 95% of you got A. F equals MA. Good. Question 2, as 80% of you got, if we're staying in the same car, we got the same acceleration. I mean, sometime you should do not do this. Try very hard not to be going 45 miles an hour while someone else in the car is going 35 miles an hour. That's generally a bad idea. Likewise, if they're accelerating and you're not, that's generally considered a bad thing. Accelerations are equal. What's not necessarily equal is the forces acting on each body. That's a different question. 3 and 4. Take 2. 2 minutes. And there's a typo here. As before, sorry, you're tiring and the cabinet is slowing down. Yes, Kyle. All the participation points should be equally weighted. I goofed on entering them. That'll be fixed. Shouldn't take that long, but it won't be today. Okay, that's time. Put in your best guess for 3 and 4. And Melanie, 3 and 4 are D and E, by the way. Oh, you're moving on to F. I see. Okay, that's fine. Okay, correct answers are equal force by Newton's third law. I push cabinet, cabinet pushes me. That's a third law pair. Question 4. Let's reason about the acceleration. My velocities are -10, -9, -8, -7, -6. What am I doing? What direction am I changing my velocity in? Do I add or do I subtract from -10 to get to -9? I add. -10 plus 1 is -9, plus 1 is -8. I am increasing from a negative quantity, increasing my velocity, although I'm decreasing my speed. My acceleration is upward. By F equals ma, my net force is upward. Correct answer is A for 4. Okay, that's 4 in. Turn to your neighbor and discuss real fast. What do you need to review? What are you getting and what is hard? All right, let's bring it together. Where are you struggling? What's hard? Ask me a question. Nope. Okay. Waiting. Sure. So here's the skill that we practiced a bunch in the first quarter of the semester. Velocity versus time, slowing down while moving upward. Slowing down while moving downward. Velocities are negative and getting less so. Which direction is my acceleration? What's the slope? Is this positive or negative slope? Positive slope, positive acceleration, positive net force. Okay, 5, 6, I erased choice A, I think. And I would reword this as planet. No need to apologize. Will there be a file upload on last year's final? Yes, I probably can't do that tonight. It'll be tomorrow. Are most questions related to this year's final? I'm going to go in and edit and remove the questions that are irrelevant so you don't have to guess. Or I will list, if I can't edit it, I will say in the post which ones are not. Anyway, 2 minutes for 5 and 6. Huh? Okay, 10 seconds. What's your best guess? Get a lot of people using the wrong units for 5. What's weight? What kind of an entity is it? The force. What do we measure forces in? Always. Correct answer is E. 6. What's the rule for determining what exerts forces on you? Rule 1. Is there a planet nearby? Is there a planet nearby? You better darn well exert a weight, include a weight force. Step 2, what else is touching it? Is the ground touching the cannonball? Is the cannon touching the cannonball? There is no other force. Correct answer is 6B only. A lot of people that missed that one. Questions about 6. Identifying forces is absolutely crucial, not just for the force module, but for the energy module too. If you are confused, ask. Okay, Noah asked, why is the force from the cannon not included when the force is what is putting it through the air? Well, when the cannonball was in the cannon is capable of exerting a force on it. But remember, force is not something that an object has. Force reflects how two things push each other. If the cannon has pushed the cannonball out of the cannon is no longer capable of pushing on the object through the air further. Again, force is not something the cannonball has. Force is when something is pushing on the cannonball, and the cannon is no longer touching, the cannon is no longer pushing on it. Follow-up to the follow-up, Noah? Follow-up to the follow-up, anyone? Again, please go down the checklist, that magical checklist. Is it a planet? Yes, wait, done. Is it touching? Consider your dictionary of forces. What kinds of forces have we learned about? Okay, 7, 8. Was there a typo in here? Julian, what I incorrectly entered was the participation points should all be weighted equally. So I think I entered the first one as 80 points, then 20, then 20. They should all be worth the same. So I think I got to change it to 20, 20, 20. They are in categories rather than raw points. So as long as they're the same weighting, it doesn't matter. If I have them all add up to 20, then the last week, which is 1/4 of that, I won't divide evenly. Okay, 1 minute left for 7, 8. Oh, 2 minutes. And let me strongly encourage you, draw a diagram for 7. Julian, the number of points, actually for everyone, for the participation points, the number of points don't actually affect anything because the grading scheme, the grade book calculates per category and then weights the categories. All you need to know is that the participation is 20% of the grade and all the weeks are counted equally. You want to know what your participation fraction is, Get your participation, and that's take 20% of the grade, that's it. Amy, that's fine. Just start a new one. Okay, last chance, 10 seconds, 10, 9, 8, 7, 6, 5, put in your best guess for HI, which is to say 7, 8. Okay, let's walk through this because based on the 3 o'clock class and what I'm seeing for all y'all, identifying the forces is hard. Let's review this. Okay, so again, the algorithm. Is there a planet nearby? Yes, weight force done. And then if it touches, it can exert a force. What is touching? What objects are capable of exerting a force on me? The ground and the child. What nature of force does the ground exert upward on me? Normal. Let me ask in a follow-up, what kind of force do I exert on Nalo? Normal. Therefore, what kind of force does he exert on me? Normal. It's always, Newton's third law of pairs are always the same kind of force. Note, it is not his weight force. He does not exert a weight force on me. Weight force is exchanged between planet and sun, planet and professor, not two macroscopic objects. Okay, so child sits on my shoulders. I'm standing motionless on the floor. Which direction does friction act? And what is keeping that friction from pushing you? Trick question. There is no friction force. You're just standing there. Well, if the only force acting, if there were a friction force, you'd have to accelerate. If you're standing motionless, just standing there and staying there, there could be no horizontal force. So there is no friction force. Correct answer ABC. Wait, yeah, correct answer ABC. Okay, Ryan asked, the weight force is still applied to your body. Yes, there is a weight force of Earth on you. What I said, to be specific, what I said is the force of child on you. That is a normal, not a weight force. It might be equal to their weight numerically, but the nature of the force is not a weight. The nature of the force is a normal. Yeah. 8. A lot of people miss this. DE. And the biggest, most common thing is people said C. I want to emphasize, like I emphasized, and please write this down if you missed this. Weight, force, gravity has a third law pair. A lot of people are missing this and miss this in the quiz and miss this in the homework and miss this in the midterm and are on track for missing this on the final. Weight, force, gravitational force has third law pairs. If Earth pulls me, then I pull Earth. Exactly. Weight is not an exception. What is the nature of the third law pair that Earth pulls me down? What kind of force is the third law pair? Weight force. Also, I gravitate the Earth upward. There may also be a normal force interaction exchange between you and the planet. That is not the third law partner. Fact is, you gravitate. Not just yo mama, who's so massive she gravitates the Earth. Everything gravitates everything else. We just only notice significant magnitudes when it is an astronomically large object acting on us. Anyone want to ask a follow-up about the nature of third law of gravity? Still a whole bunch of people are missing this. No follow-ups for that? Okay, so again, the correct answers for 7, 8 are ABC and DE. Nine, 10. And typo here. Earth. Be louder in here. Talk to your neighbors. Argue about your answers. Tell each other why. Ask each other why. Bella, we're on J and K, by the way. Okay, 10 seconds. Put in your best guess. And time's up. Can anyone tell me what I just said about the nature of third law of weight force? It is always the same kind of force. The third law of pair to the weight that the earth exerts on the dog is that the dog exerts on the earth. D. If you got this wrong, please write this in big, bold letters on the top of your notes and study it 1,000 times. If earth gravitates dog, dog gravitates earth. It's not a normal force. It's not a friction force. It's a gravitational force. Questions about that? Still a lot of people missing this. Please. Seven. The normal force of U on child belongs on the child's diagram. As for the forces on you, that's a force on child. Still no one wants to ask about 9? No. Okay, 10. Constant speed, what's the acceleration? What's the net force? How's the tension related to the weight? What's the weight formula? 60 newtons. Done. B is the correct answer for 10. And again, here's the reasoning. If it's constant speed, straight line, There's no acceleration. If there's no acceleration, net force is 0. If net force is 0, tension is equal to weight. If tension is equal to weight, tension equals mg, done. Now you look shell-shocked. Which step? No, just that's a lot. That's allowed. Okay, we've been through 6 more. Turn to your neighbor and discuss the last 6 questions. Where are you confuzzled? Where are you missing points? And then I'll take questions. Okay, question me. Where are you struggling? Where's your neighbor struggling? Questions. No? Move on? Moving on. Typo on 12, it's meters per second, not meters per second squared. I use the word steady. Big hint, I'm talking about velocities. Okay, time's up. CC. Hey, good. Most people got the first one. Second one less so. Here's the reasoning for the second one. You're moving at a steady 3 meters per second. What's your acceleration? What's the net force? Which is bigger, tension, normal, or weight? Trick question, they're equal. So how do you calculate the force that you exert on the scale? Calculate your weight, you're done. Questions? Hey, follow-up question of my own. What do scales measure? Normal force, very good. How do you know that scales don't measure your weight? Jump on them. Is your weight changing? Is the scales reading changing? Scale is not reading your weight. Scale is measuring how hard you push on it. Your scale measures the normal force. If the normal and the weight force are the only two forces acting on you, and you're not accelerating, then normal equals weight, and the scale can infer your weight. But your weight force cannot be felt by anything other than the planet. Force is equal to it could be measured, but not the weight itself. Again, correct answer is CC. 1314. Draw a diagram, write the law. I do. You may come to office hours. Do you have time for office hours? No. Nope. It is on the syllabus. It is on Canvas, but I can also tell you here. 10:45 to 11:45, Monday, Wednesday. Can you meet? Okay. If you can't, I would bring it to you, but it's much more easier for me. One minute. Oh, 2 minutes. Okay, time's up. 13. B. So net force is 20 newtons right. Then to find the acceleration, F over m. What's m? How do we get m? You got the weight. Weight equals mg to get the mass. Correct answer, 2.6 meters per second squared. 14. What forces add up to be the net force? I think normal's winning. Hopefully the astronaut is being accelerated upward. Net force equals ma. Y'all agree with this? Safi, you missed the question. Okay, what am I asking for? Correct answer is E. Hey, turn to your neighbor and argue about this. Because as I said, we're still getting about half of you missing this. Like everyone to get this. Still, the total force has to be upward if he's not slipping down. If he's accelerating upward, the net force from the chair must be upward. That'll come from two sorts of things, a normal and a friction, but the total of the normal and the friction must add up to 1400. Okay, someone asked me about 14. If you're struggling with it, you're not alone. There's only one way to improve on these things. That's to dive in and engage and ask questions about them. Don't just wait for the physics to occur to you. Question. Your hand was going vertical. Sophia asked, why don't you subtract? Correct. You're not accelerating downward. Let's build up the pieces. Net force is the upward force minus the downward force equals ma. This goes up, this goes down, plus minus. Which direction is acceleration? If you're launching a rocket, for the sake of the astronaut, I sure hope that the acceleration is upward. Solve for n, I would add w to both sides. Sophia, I'm not sure that answers your question, though. You want to post a follow-up to that? Anyone want to ask a follow-up about this? Astronauts in the ocean? Sure. There'll be a nuclear submarine and they'll be launching nukes from underwater. Last chance for questions about 14. Follow-ups to the follow-up to the whatever. We are way ahead of schedule. Well, good. Ask me a question like I've been asking. Okay, so let's see. Sophia has got a good follow-up here. I am subtracting it. I'm not subtracting anything. Well, okay, so again, build this up piece by piece. Net force. What is the net force? Net force is, there are two things. There's a normal of the back of the chair pushing the astronaut up, and there's a weight force of the Earth pulling the astronaut down. Net force is normal minus weight, right? And net force is always equal to ma. I could plug in to the values of this formula. I know a formula for weight. Weight is mg, which in this case is 660 newtons. I could plug in F equals ma, 67 times 11 is 740 newtons. So I get the equation n minus 660 equals 740. What's n? Not sure that I answered the question, though. Have I convinced you? Have I sold you this product? You said you're still confused about 14. Ask me a question. You think you got it? MA, mass times acceleration. I give you the mass as 67 kilograms. I give you the acceleration as 11 meters per second squared. 67 times 11 is 740-ish. I said just after lunch. The space station is very close to the Earth, gravitationally. Infinitely far. Gravity is an infinite range force. Now, you could say, how far do you have to be to experience ignorably small gravity? Well, then you have to tell me what ignorably small is. You'll get 1% of your weight force when you are most of the way to the moon, I think. So at the moon's range, you're far enough out. I think, if I'm doing that right. Yeah. Okay. Last chance for 14 and moving on. 15, 16. PQ. Because he's the dancing queen. So does the pulley have a mass and a moment of inertia, or is the pulley freely spinning? Then you can't exert different forces. Pulling basically on one end of the rope versus another end of the rope, and the pulley's not helping one side or the other side. You can't exert different tensions. It has to be the same force on either side.
So you're saying if you're pulling this way, the total is number 5. It's only one.
If there's 5 newtons on this side of the rope, there's 5 newtons on that side of the rope. And the reason why is because since we say ropes are small, mass is ignorably small. Mass times acceleration is 0. So the total force on the rope must be 0. The left side and the right side must be pulled equally. So the left side and the right side must pull equally. If the rope has a significant mass, for instance, if we're talking about the physics of an anchor chain of a big ship, you better believe that the top of an anchor chain and the bottom of the anchor chain can have different forces. Sorry?
Is that an exponential term that you account for, or is it, how would you, physics is beyond this, but like, how would you account for the further the rope goes, the more weight you have?
At any given point, well, let's see, at the bottom of the rope, the tension upward is equal to whatever the rope is supporting. If the chain is just dangling, the very last link of the chain isn't supporting anything, if there's no force pulling down, then and it doesn't need to exert any force up. The very last link of even a massive chain, it exerts no tension force. The very top link, that would have a tension force of whatever it's supporting, if anything, plus the weight of the chain itself.
You just do the math on each section of the chain.
Yep. You can take any fraction of the chain and find the fraction. Now, a fun problem is to have a chain on a frictionless surface where one link is over the edge, and then more and more and more mass goes over the edge, more and more and more force, more and more tension on the remaining portion. That gets to be a very interesting problem indeed. That's beyond the scope of the class. That's beyond the scope of the class. Okay, number 15, if I tell you stuff, tell you the acceleration is 5 meters per second squared, F equals ma, baby, 500 newtons. How, follow-up question, I didn't ask this in the question, but you know the answer to this. How can there be a steady speed and a steady acceleration? Anyone? Huh? Changing direction, what do you mean? What kind of motion has steady speed and steady acceleration? Rotation. Where I got this problem, I adapted this problem from saying you've got a rope supporting something moving in a circle. I think the original problem gave you the speed and the radius and asked you to determine the tension. 16. How do you do this? Weight equals mg. M doesn't change, but G does. How I would do this is 2 steps. First, I would find their mass, which doesn't change. 800 equals 9.8 times 80. And then I'd say if their mass is 80, M is 80, mg on Mars, 80 times 4 is 320 newtons. C. I'm rounding. Follow-ups to that. A bunch of people got C. Good. I will give a hint here. A fair number of people told me B or A. Kilograms aren't weight. Kilograms measure mass. Newtons measure weight. Follow-up, yes. Five meters per second squared is acceleration is A. Alpha would be the radians per second squared. And for that matter, if you're going at steady speed, alpha would be 0. You would not be changing your radians per second. Question? F equals ma. Where's V and F equals ma? There is no V. V is irrelevant. David, what you thinking? No? Okay, 17. You should do 17 now. Yeah, do 17. 17. The same coefficient applies to both. Same force applies to both. Same normal applies to both. Same friction force applies to both.
Yes, they're incorrect.
Okay, there are a couple of pieces to 17. You must know the equation for kinetic friction. Now, how much friction is there? What is the magnitude of the friction force? What must it be? Equal to the other forces. How do you know that, David? It's not accelerating. The freight is sliding with constant speed. The forces are in balance. Why do we add the forces instead of subtracting them? Please note, read carefully, pulls in the same direction. 420 plus 260 is the friction force must balance 680. What about N? Where do we find normal force? All other things being equal, I don't think there's anything else acting vertically except for normal and weight. So normal equals weight unless you're phasing through the floor or shooting into the sky. I don't think that's happening. So weight equals mg. 500 times 10-ish. Great, solve for mu k. Correct answer, C, 0.14. Turn to your neighbor, discuss for 2 seconds. This whole process. Then I want 3 questions, then we'll get out of here. I mean, you just get that the work done by friction is negative of the work done by the guys. To get the coefficient of friction, you still need the friction equation. All right, last chance for questions for today. Give me a question. Where are you struggling? Number 20? Okay, so the 3 o'clock class didn't get through, didn't get past 17, so I'm gonna to end it here. Kyle, is the last year's final exam a good resource? Yes. So are the midterms from this semester. So are the homeworks and the quizzes for this semester. All of the final questions come from things you've already seen. There should be 0 surprises. Okay, I'll stick around for a few minutes, but I don't want to go to the rest of them. Yes, Noah, cheat sheet, 8.5 by 11, cut it into 2 pieces, front and back. Question. So all questions come from either past exams, quizzes, or homeworks, yes. Mu is a ratio of 2 forces. Mu has no units. Mu needs no units. What would you multiply newtons by to get newtons? If you've got F equals mu n, F is measured in newtons. Normal is measured in newtons. Mu is unitless. It's a ratio. It's a percentage. Wait, hold on. Let me hit stop recording.